Hi, I'm Bob. Welcome back to the Solutions to the Exercises for the Textbook Microeconomics Theory and Applications with Calculus by Professor Jeffrey Perloff. We will address the problems in the second section, Attitudes Toward Risk, of Chapter 16, Uncertainty. If you find the solutions helpful, please subscribe to my YouTube channel. Thank you. Here's exercise 2.1. Guojun offers to bet Kristen that if a six-sided die comes up with one or two dots showing, he will pay her $3. But if it comes up with any other number of dots, she will owe him $2. Is that a fair bet for Kristen? A fair bet is a wager with an expected value of a certain initial wealth. Here, the initial certain wealth is 0, so a fair bet should have an expected value of 0. Kristen's expected value from the bet is negative, so it is not a fair bet for her. It is an unfair bet against her. Let's solve exercise 2.2. Jan's utility function with respect to wealth is u, which is equal to the squared root of w. Plot her utility function. Use your figure and calculus to show that Jan is risk-averse. We draw the utility curve with respect to wealth. It is concave to the wealth axis. We can show that the expected utility of wealth is smaller than the utility of expected wealth. Suppose the two possible wealths are 0 and 9. The expected utility equals 1.5, which is smaller than the utility of the expected wealth of 4.5, which is 2.12. That indicates the utility function is concave. Jan is risk-averse. Using calculus, we find that the first derivative of the utility with respect to wealth is positive, but the second derivative is negative. It implies that her utility rises with wealth, but at a diminishing rate. It corresponds to a concave utility curve. We can also calculate the Arrow-Pratt measure of risk aversion. It is positive, meaning that the individual is risk-averse. Let's address exercise 2.3. Jan, in exercise 2.2, may buy stock A or stock B. Stock A has a 50% chance of being worth $100 and 50% of being worth $200. Stock B's value is $50 with a chance of half and $250 with a probability of 50%. So that the two stocks have an equal expected value but different variances. So that Jan prefers stock A to stock B because her expected utility is higher with stock A. We tackle the problems in 3 steps. In the first step, we calculate the expected values of the stocks. The expected value is the weighted average of the values of each possible outcome, where the weights are the probability of each outcome. The expected values of the stocks are identical. In the second step, we compute the variances of the stocks. The variance is the weighted average of the squared differences between the actual and expected values for each possible outcome, where the weights are the probability of each outcome. Stock B's variance is larger than Stock A's variance. In the third step, we calculate the expected utility each stock gives Jen. Stock A has a higher expected utility than Stock B. Jen prefers Stock A over Stock B. Let's answer exercise 2.4. Suppose that an individual is risk-averse and has to choose between $100 with certainty and a risky option with two equally likely outcomes, 100 minus X and 100 plus X. Use a graph to show that this person's risk premium is smaller the smaller X is, the less variable the gamble is. We consider two risky options. Option 2 with 100 minus x2 and 100 plus x2 is more variable than option 1 with 100 minus x1 and 100 plus x1. The graph shows that the risk premium for option 2 is P2 and the risk premium for option 1 is P1. P2 is larger than P1. The less variable or less risky option 1 in this exercise, has a smaller risk premium for an individual with risk aversion than the more variable option 2 in our case. Let's go to exercise 2.5. Given the information in solved problem 16.2, Irma prefers to buy the stock. Show graphically how high her certain values would have to be for her to choose not to buy the stock. From the textbook, her expected utility from buying the stock is 133. It corresponds to the point F. We consider a certain value that gives her the same utility of 133. That corresponds to the point G on the utility curve and a certain value of W tilde on the values axis. Her certain values must be equal to or higher than W tilde for her to choose not to buy the stock. Let's address exercise 2.6. In solved problem 16.3, what is Jen's risk premium if her utility function were log W? We calculate Jen's risk premium in 4 steps. In the first step, we calculate her expected utility from buying the stock. The expected utility is the weighted average of the utilities under each possible outcome, where the weights are the probability of each outcome. It is around 5.12. In the second step, we find the certainty equivalent. The certainty equivalent is the amount of certain wells that produces the same utility as the risky option. The certainty equivalent is $167.3. In the third step, we calculate the expected wells of the stock option. The expected wells is the weighted average of the wells of each possible outcome, where the weights are the probability of each outcome. It equals $171. In the fourth step, we compute the risk premium P, the difference between the expected wells and the certainty equivalent. John's risk premium is $3.7. The risk premium is the amount of a risk-averse person would pay to avoid taking a risk. In our exercise, $3.7 is the maximum amount she's willing to pay to get a certain wells of $171 instead of buying the stock. It can also be seen as the minimum amount she's willing to receive to accept the risky option of purchasing the stock rather than the certain option of having that certain wells. Let's solve exercise 2.7. Hugo has a concave utility function of u equal to w to the power of 0.5. His only asset is shares in an internet startup company. Tomorrow, he will learn the stock's value. He believes that it is worth $144 with a probability of 2/3 and $225 with a probability of 1/3. What is his expected utility? What risk premium would he pay to avoid bearing this risk? We tackle the problem in 4 steps. In the first step, we calculate Hugo's expected utility from buying the stock. The expected utility is the weighted average of the utilities under each possible outcome, where the weights are the probability of each outcome. It is 13. In the second step, we find his certainty equivalent. The certainty equivalent is the amount of certain wells that produces the same utility as the risky option. The certainty equivalent is $169. In the third step, we calculate the expected wells of the stock option. The expected wells is the weighted average of the wells of each possible outcome, where the weights are the probability of each outcome. It equals $171. In the fourth step, we compute the risk premium P, the difference between the expected wells and the certainty equivalent. His risk premium is $2. The risk premium is the amount a risk-averse person would pay to avoid taking a risk. In our exercise, $2 is the maximum amount he's willing to pay to get a certain wells of $171 instead of buying the stock. It can also be seen as the minimum amount he is willing to receive to accept the risky option of purchasing the stock rather than the certain option of having that certain wells of $171. Let's go to exercise 2.8. Mary's utility function is u equal to w to the power of 0.33, where w is wells. Is she risk-averse? Mary has an initial wells of $27,000. How much of a risk premium would she require to participate in a gamble that has a 50% probability of raising her wells to $29,791 and 50% probability of lowering her wealth to $24,389. We find the Arrow-Pratt measure of risk aversion to determine whether she is risk averse. It equals the negative of the second derivative of the utility function with respect to wealth divided by the first derivative. The Arrow-Pratt measure of risk aversion is positive, meaning that she is risk averse. Next, we find her risk premium. We calculate the expected utility of participating in the gamble. The certainty equivalent wealth that gives the same utility. The expected wealth of the gamble. And the risk premium she is willing to pay to avoid the gamble, step by step. Her risk premium is $90. She is willing to pay a maximum of $90 to have a certain wealth of $27,090 instead of participating in the gamble. In other words, she is indifferent between the two options, either giving her a certain wealth of $27,000 or taking the gamble. Let's address exercise 2.9. Would risk-neutral people ever buy insurance that was not fair? Explain. No. A risk-neutral person's utility curve is a straight line. She is indifferent between not buying insurance and buying it when it is a fair bet. She does not care how much risk she faces. She only cares about the expected value or wealth. If the insurance is not fair and biased against her, she will not buy it because the expected value of the insurance is lower than not buying it. Let's answer exercise 2.10. Lisa just inherited a vineyard from a distant relative. In good years, she earns $100,000 from the sale of grapes from the vineyard. If the weather is poor, she loses $20,000. Lisa's estimate of the probability of good weather is 60%. For Part A, calculate the expected value and the variance of Lisa's income from the vineyard. The expected value of the income is the weighted average of incomes of each possible outcome, where the weights are the probability of each outcome. It is $52,000. The income variance is the weighted average of the squared differences between the actual and expected income, where the weights are the probability of each possible income. It equals 3.456 times 10 to the power of 9. For Part B, Lisa is risk averse. Ethan, a grape buyer, offers Lisa a guaranteed payment of $70,000 each year in exchange for her entire harvest. Will Lisa accept this offer? Explain. We compare the utility of growing grapes to the utility of the guaranteed payment. Since Lisa is risk-averse, her expected utility of the two possible outcomes is smaller than the utility of the expected value of those two outcomes. We already calculated the expected value in Part A. It is $52,000. That is to say, the expected utility is smaller than the utility from a certain income of $52,000. It is inequality 1. Because the utility increases with income, $70,000 gives her a higher utility than $52,000. It is inequality 2. The two inequalities imply that the guaranteed payment of $70,000 gives Lisa a higher utility than that from running the vineyard. She will accept the offer. The graph clearly shows the relationship. For Part C, why might Ethan make such an offer? There were at least 3 explanations. First, Ethan is risk-preferring. He is willing to pay to make a fair bet. The graph shows that his utility curve is convex to the well's axis. The grape harvest expected utility is EU. His certainty equivalent gives him the same utility as the EU. If his certainty equivalent is equal to or greater than $70,000, he is willing to offer Lisa $70,000 in exchange for the bet. The second possibility is that Ethan is risk-averse and gets pleasure from growing and harvesting grapes in the vineyard. Considering pleasure and satisfaction, Ethan's certainty equivalent could equal or exceed $70,000, even though his utility curve is concave to the well's axis. The third explanation is that Ethan makes a mistake. He might not have accurate information about the probability of good weather. He might not calculate the expected values correctly. Therefore, he did not realize his offer was too high. Let's go to exercise 2.11. Joanna is considering 3 possible jobs. The following table shows the possible incomes she might get in each job. For each job, calculate the expected value, the variance, and the standard deviation. If Joanna is averse to risk, what can you predict about her job choice? What if she is risk neutral? We calculate the expected value, the variance, and the standard deviation for each job using their definitions. They are weighted averages. We first consider case 1, in which Joanna is risk-averse. Job 1 and Job 3 have identical expected values, but Job 3 is free from risk. A risk-averse person prefers Job 3 over Job 1. We rule out Job 1. Whether she will choose Job 2 or 3 depends on her utility function. Job 2 has a higher expected value than Job 3, but Job 2 has more risk. If the certainty equivalent for Job 2 is higher than $30, then she will choose Job 2. Otherwise, she will select Job 3. Next, we consider case 2 in which Joanna is risk neutral. A risk neutral person does not care about risk. She chooses the job that gives her the highest expected value, because maximizing expected value maximizes utility. She will choose Job 2. A risk-neutral person's utility curve is a straight line. Let's solve exercise 2.12. Suppose that Irma's utility function with respect to wealth is as follows. Show that for W less than 10, Irma's Arrow-Pratt risk aversion measure increases with her wealth. We write down the Arrow-Pratt measure of risk aversion formula. The first derivative and the second derivative of the utility with respect to wealth are computed. We have the expression for the Arrow-Pratt measure. Then we differentiate the Arrow-Pratt measure with respect to wealth to find how the measure changes with wealth. We find that as long as wealth W is smaller than 50, the Arrow-Pratt measure of risk aversion increases with wealth. That range includes the case where W is less than 10. Let's find answer to exercise 2.13. Carolyn and Sanjay are neighbors. Each owns a car valued at $10,000. Neither has comprehensive insurance. Carolyn's wealth, including the value of her car, is $80,000. Sanjay's wealth, including the value of his car, is $20,000. Carolyn and Sanjay have identical utility of wealth functions. Carolyn and Sanjay can park their cars on the street or rent space in a garage. In their neighborhood, a street parked car has a 50% probability of being stolen during the year. A garage parked car will not be stolen. For Part A, what is the largest amount that Carolyn is willing to pay to park her car in a garage? What is the maximum amount that Sanjay is willing to pay? We compute the risk premium for each person. The risk premium is the amount that a risk-averse person is willing to pay to avoid taking a risk. In this exercise, it is the maximum amount that a risk-averse person is willing to pay to park her car in a safe place instead of a risky place. We calculate the risk premium in 4 steps, as in previous exercises. In the first step, we compute the expected utility of parking the car on the street. Remember that the wealth of each state is the total wealth. If the car is not stolen, the wealth is $80,000. If the car is stolen, the wealth is $70,000. Carolyn's expected utility is 89.08. In the second step, we calculate the certainty equivalent that gives Carolyn the same utility. It is $74,894.6. In the third step, we find the expected value of parking the car on the street. It is $75,000. In the fourth step, we calculate the risk premium, which is the difference between the expected value and the certainty equivalent. It is $105.4. Carolyn is willing to pay a maximum amount of $105.4 to park the car in a garage. For Sanjay, we follow the 4 steps to find the risk premium, which is the maximum amount Sanjay is willing to pay to avoid the risk. It is $515.6. Sanjay is willing to pay a maximum amount of $5,015.6 to park the car in a garage. Sanjay would like to pay more than Carolyn to avoid the risk, although they have the same utility function, because the car accounts for a relatively large proportion of Sanjay's total wealth. Compare Carolyn's willingness to pay to Sanjay's. Why do they differ? Include a comparison of their Arrow-Pratt measures of risk aversion. We compute the Arrow-Pratt measure of risk aversion. It equals 3 over 5W. We differentiate it with respect to wealth to see how it changes with wealth. It's negative, meaning that the Arrow-Pratt measure decreases with wealth. A higher wealth reduces the Arrow-Pratt measure. In other words, the person with a higher wealth has a lower degree of risk aversion. Carolyn is wealthier than Sanjay, so she is less risk averse. Let's adjust exercise 2.14. Based on the information in the application gambling, provide at least 3 reasons why many risk-averse people gamble in casinos. First, they might enjoy gambling and get pleasure from gambling. Considering pleasure and satisfaction, some risk-averse people will take the risk. Second, they might make mistakes. They might have inaccurate information about the probability of each possible outcome. They might not know the expected utility theory or be unable to calculate the expected values and the expected utilities correctly. Third, the satisfaction from winning might be much higher than the frustration from losing in the gamble, which alters the expected utility calculation. Let's solve exercise 2.15. Do the following utility functions imply risk aversion, risk neutrality, or risk preference? We calculate the Arrow-Pratt measure of risk aversion to tell whether the utility functions imply risk aversion, risk neutrality, or risk preference. Part A and Part B's utility functions have positive Arrow-Pratt measures, implying that people with these utilities are risk-averse. The utility function in Part C has a negative Arrow-Pratt measure, meaning that people with this utility function are risk-preferring. The utility function in Part D leads to a zero Arrow-Pratt measure, implying risk neutrality. Thank you very much for watching this video and solving all the exercises in this sector. See you soon. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.